So this next one says 2x e to the power of x squared dx, and it wants the antiderivative again. Now, the special thing about this problem is there's the variable e right there. Remember, e stands for 2.7, roughly speaking, so it's technically not a variable, it's just kind of like a number. It's like pi. We use a symbol for the number 3.14, just like we use the symbol e for the number 2.7 roughly. So the trick for these problems is this. Anytime you see the variable e or the letter e in your problem, the u is going to be the exponent. So whatever the exponent is, that's automatically has to be chosen as your u. So if that is my u, what would my du be? What's the derivative with respect to x? The derivative of x squared is actually 2x. And I'm going to multiply both sides by the dx to get rid of the dx from the denominator and to write down 2x dx. Now, this process is time consuming. As a matter of fact, this step right here, we're going to be erasing it in future problems. We're going to do the stuff mentally. We're just going to take the derivative of x squared, write down the 2x, and right away, right next to it, we're going to write down the dx. Instead of writing it once on the denominator and then saying, let's multiply both sides by the dx, we're just going to do that step mentally and skip the middle line. That way we can save a little bit of time. So according to this table, every time I see 2x dx, I'm supposed to erase it and write down the letters du. Okay, so I see 2x and a dx. I'm supposed to grab them both, grab them and erase them and write down in their place du, because that's what we said in our little table, in our little setup. Now, the letter e itself, the one that's in the base right there, is going to stay. It's not going to change. It's going to keep in the problem because there's nothing in my table to tell me to replace e with anything. But in my table, I said that anytime I see x squared, I am supposed to erase it and write down the letter u. So the exponent is no longer going to be x squared. It's now going to be the variable u. Okay, how do you know that you're doing this right? The new problem that you just wrote does not have any letter x's. That's how you know you're doing it right. If there's any x's right here on this step, then we know we messed up somewhere. It looks like there's no x's, so we're good to go. So now the question is, what is the antiderivative for e to the power of u du? And the antiderivative of e to the power of u du, this whole thing is just e to the u plus c. That was actually a formula that we learned before in the previous chapter. And that's it. You're finished, because now all you have to do is replace the letter u with x squared, because that's what it was in the first place. So e to the x squared plus c. And that's because the x squared replaces u replaces x squared. And we're now completely done with the problem. So this is an example of how we do the exponentials. So I'm going to go ahead and number the steps so you can kind of remind yourself how I did these things. So here's a recap of what we did in the problem. So step number 1 was deciding the u should be the exponent because we saw the e in the problem. Step number 2 was taking the derivative. Step number 3 is going to be to multiply both sides by the dx so that the du is isolated from all the dx's. In the future, I'm going to be combining step 2 and step 3 together to save time. Then once I did that, I went on to the original problem and I looked for the 2x and a dx. I grabbed them in my hand and I erased them and I wrote in their place the du. Then I copied the letter e. Then I changed the variable x squared to the variable u. That was step number 5. From here to there, all I did is I just removed the color so that we can kind of clearly see what's going on. And the antiderivative of e to u, the whole thing goes away and it gets replaced with e to the u plus c. And then finally, step number 7 is replace the letter u with the original letter x squared. And we're basically done with the question.